Page 342, number 64. Create a scatter plot of the data. Find a trigonometric model that fits the data. What is the period of the model, and what is the amplitude of the model? Okay, let's pull out our graphing calculators. Let's let our calculators do most of the work here for us. So I'm going to get my calculator out, and we know we can enter data by pressing our stat key and then enter. Let's enter our months into list 1 and our sales into list 2. So your months, the numbers 1 through 12, just stand for the 12 months of the year. And our sales stand for the amount of sales in each of these months. And we can see the sales go up and down. So in January, let's say the sales are 13.46. And let's get all of this data into list 2. Now you'll notice when you graph this in, or when you enter this in here, you'll notice the values go down and then they go up again. Now, one thing I don't like about this particular data set is that when our values go up and down, they go up and down by you'll see some of the exact same numbers repeating. Now, never in real life do we see these kind of exact values. So normally when we make a model, we're making an approximation of what we think is going to happen every month. These values here appear too exact to be real data, but we'll go with it. Okay, so first of all, to create a scatter plot, I can make a scatter plot on my calculator by not using the y equals menu, but using what's right above it, pressing second y equals. I could turn on a stat plot. The type is going to be a scatter plot. Let's use that open circle as a mark. And if I press my zoom key, the ninth choice here, I'll scroll down to the ninth choice, is zoom stat. To zoom in on our statistics. And when we graph those points, we can see that they go downward and then upward. We can see that pattern. It looks like a sine or a cosine curve. So there's our scatter plot. I'm going to pull that out, put that on my page over here. Now find a trigonometric model that fits the data. Let's press our stat key on our calculator, go over to calc. We've found regression equations in the past. What I want to find now is a sine regression. Now you might say, wait, doesn't this look like a cosine curve because it starts up here? Well, looking on here, you won't find a cosine regression, so we're going to have to go with sine. So we want to find a sine regression equation of the data in list 1, comma, list 2. And I'll press enter. Now it tells us that our basic sine curve y equals a times the sine of bx plus c plus d. And it tells us the values of a, b, and c. So let's write that down. And I'm going to keep a, b, and c to 2 decimal places. So y is about equal to 6.3 times the sine of bx plus c, so 0.52 x plus c, which is 1.57, and then plus d. So d is it's almost exactly equal to 8. Okay, let's put our calculator aside. Now the problem says, what is the period of the model? Now the period of the model should be 12 months. This repeats every 12 months. What is the amplitude of the model? The amplitude is the amount that this goes up and down. And the amplitude is given right here. So the amplitude is 6.3. So we have our amplitude of 6.3. A few other things. This value right here, D, is my vertical shift. So if I go 1, 2, 3, 4, 5, 6, 7, 8 units, there's my vertical shift, meaning my sine curve goes up and down around that axis, up 8 units. So my period, 12 months, makes sense based on the situation. We can also find our period because we know that 2 pi over this value here, b, is equal to our period. So if we say 2 pi over 0.52, that'll give us our period. Let's pull that calculator out again. And if I type that in there, 2 times pi divided by 0.52, we should get an answer of about 12. And there it is. So my period, it should be 12 because we're talking about a 12-month cycle.